This lesson shall cover the only topic in geometry that is asked in a banking examination, that deals with measurements. Measurements is also known as mensuration. It is that area of geometry where you measure area, the perimeter, volume or surface area of a two-dimensional shape or a three-dimensional solid. We shall look at some of the key formulae on measurements based on the type of questions that are asked in the IBPS, and also see some example of questions that can be asked. The first formula is regarding squares. A square is a shape with four sides where all four sides are of equal length and all four sides are perpendicular to each other. Assume that each side of a square is equal to A. The area of the square then is A square. The perimeter of the square is 4A and the diagonal of a square is given by A root 2. The next shape we shall look at is a rectangle. Now a rectangle is a shape with four sides where each side is perpendicular to the other side, that is, two sides of a rectangle make the angle 90 degrees just like a square. However, the four sides are not of equal length. Two sides will be of one length and the other two sides would be of another length. The longer side of the rectangle is called the length and the shorter side is called the breadth. Let us denote it by L and B. The area of this rectangle is L multiplied by B. The perimeter is 2 times L plus B. The diagonal of the rectangle is root over L square plus B square. The third shape we are looking at is a parallelogram. Now a parallelogram is a four-sided figure where opposite sides are parallel to each other. A rectangle and a square are also parallelograms. They can said to be special parallelograms where the sides are perpendicular to each other as well. Let us say that the longer side of the parallelogram is denoted by L and the shorter side is denoted by B. The area of the parallelogram is given by base into height. Now base would be any one side of the parallelogram. Height is the distance between this side and the side that is parallel to it. That is, the distance between the two parallel sides is the height. The perimeter of this parallelogram, like a rectangle, is 2 times L plus B. The next shape we shall look at is a rhombus. Now a rhombus can be said to be a special kind of parallelogram where all the four sides are equal to each other. A square is a special type of rhombus where two sides are perpendicular to each other as well. Let us say that one side of this rhombus has the length A. The area of this rhombus is given by d1 into d2 by 2, where d1 and d2 are the lengths of the diagonals. The perimeter of this rhombus is 4 times the length of one side because all the sides are equal, so hence perimeter is equal to 4 times A. We now look at the shape called a trapezium. A trapezium is a four-sided figure where two sides are parallel to each other and the other two sides are not parallel to each other. If we say that the two parallel sides have lengths L1 and L2, then the area of this trapezium is given by L1 plus L2 into D. D being the distance between the two parallel sides of this trapezium. The perimeter of this trapezium shall be the sum of the four sides. There is no fixed formula for this, so you should know the individual lengths of all the four sides. A triangle, as we know it, is a figure with three corners and three sides. The area of a triangle is given by half times base into height. Base is any one side of a triangle and the height is the perpendicular distance of the opposite vertex to this side. The perimeter of a triangle is equal to the sum of the three sides. Now there are different types of triangles. If the three sides are of different lengths, the triangle is said to be a scalene triangle. If two sides are the same length and the third side is of a different length, the triangle is said to be isosceles. If all the three sides are the same length, the triangle is said to be equilateral. If the triangle is equilateral, the area of that triangle shall be square root of 3/4 times the square of one side. And the perimeter of that equilateral triangle shall be 3 times the length of the side. Let us now look at a circle. A circle is a round shape and it has a center and a radius. Let us denote this radius by r. The area of the circle is equal to pi r square. The value of pi can be approximated to be equal to 22/7 or 3.14. The perimeter of a circle is also called its circumference. The circumference of a circle is given by 2 pi. The perimeter of a circle is also called its circumference. The circumference of a circle is given by the formula 2 pi into r. One important concept that you will have to use many times in an IBPS exam, where many questions are asked regarding this, is the Pythagoras Theorem. The Pythagoras Theorem is applied on a right-angled triangle. That is, let us say that the two perpendicular sides of this triangle have lengths A and B, and the third side has a length C. What Pythagoras Theorem tells us is that A square plus B square shall be equal to C square. This formula is extensively tested in many competitive examinations. You could be asked to find a third side of a triangle given two sides. This formula is also useful when you're solving directions problems in the reasoning section. So I have just told you about the measurement and mensuration formulae for several two-dimensional shapes. Let us now look at some three-dimensional objects and formulae for their volumes and so on. The first three-dimensional solid that we shall look at is a cube. A cube is a solid where each face is a square and all sides of this solid are the same length. Let that length be A. The volume of a cube is given by A cube. The surface area is given by 6A square and one diagonal of the cube is given by A root 3. Similar to a cube is a cuboid. If a cube reminds you of a square, a cuboid shall remind you of a rectangle. The three key dimensions in a cuboid that you must know. One is the length, one is the breadth, and one is the height. If these are denoted by L, B, and H respectively, then the volume of a cuboid is L times B times H. And the surface area is 2 times LB plus BH plus HL. A diagonal of a cuboid is given by the formula root over L square plus B square plus H square. A cylinder is an object that is shaped like a tube. It would have a certain length and its cross section shall be circular. Let's say the radius of the circle is r and the length of the tube or the cylinder is h. The volume of this cylinder shall be pi r square into h. We'll now look at the concept called a curved surface area. A curved surface area is that portion of a cylinder that is not flat, that is curved. The curved surface area of a cylinder is given by the formula 2 pi r into h. The total surface area, that is the surface area of the curved portion, as well as the two flat circles at either end, the total surface area is given by 2 pi r into h plus r. A sphere is something that is shaped like a ball. Let us say that a sphere has the radius r. The volume of a sphere is given by 4 by 3 into pi r cube. And the surface area of the sphere is 4 pi r square. The volume of a cone is given by 1 by 3 into pi r square h. The lateral surface area, that is the curved surface area, the surface area of the curved portion is given by pi r into L. and the total surface area is given by pi r into L plus r. Now if you slice this cone vertically, you see that H, R and L form a right angle triangle. So Pythagoras theorem can be applied here. Therefore, L square is equal to H square plus R square. A prism, you might recall from your science classes in school, is something that is used to split white light into the 7 colors. Anything of that shape is called a rectangular prism. That is because each side here is a rectangle and the two end sides are triangles. Let's say that the height of this prism is h and the triangle at one end has a certain area. The volume is given by the area of that triangle multiplied by h. The last shape we'll look at is a pyramid. You must be familiar with what a pyramid is like by all those photographs you might have seen of pyramids in Egypt. Now the pyramid will have a certain height h and a base that will have a certain area. The volume of this pyramid is 1/3 the area of the base multiplied by the height. Let us now look at some of the different types of questions that can be asked with regards to measurements and mensuration. The first kind of question will deal with the applied use of formulae. For example, you have a question that says the area of a rectangular plot is 5292 square feet. The length of the plot is 8% more than the breadth. What is the breadth? So we know that the area of a rectangle is length times breadth. The question says that the length is 8% more than the breadth. So L is equal to 1.08 times B. So if we substitute that in the area equation, we have 5292 is equal to 1.08 B times B, which gives us B square is equal to 5292 divided by 1.08, that is 4900, or B is equal to 70 feet. Now in this kind of a question, the data is already given to you. You just have to remember the formula, substitute the values and find the answer. It's pretty straightforward. The second question type, however, deals with something like a percentage change in dimension. For example, Rahul's bedsheet shrunk when he washed it. The length reduced by 10% and the breadth reduced by 20%. By what percentage did the area decrease? We know that area is length times breadth. So the new area now is 0.9 length multiplied by 0.8 into breadth, which is 0.72 length times breadth, which essentially means that the new area is 0.72 times the old area, which translates to a decrease of 28%. Let's now look at some tips and shortcuts regarding quick calculation of mensuration questions. The first deals with questions that have a percentage change in length and breadth. Do you remember the shortcut that was described in the profit and loss lecture and in the percentages lecture? The shortcut told you that profit percent is given by 100 times 1 plus or minus R1 by 100 into 1 plus or minus R2 by 100 and so on. We can use the same formula to calculate change in length and breadth. Let us see how. Given this formula for profit percent, this will transform to this formula for calculating a percent change in area. We shall have only two terms, R1 and R2, because area is a two-dimensional measurement. R1 could be the percentage change in length and R2 could be the percentage change in breadth. R1 and R2 could also be change in base and height of a triangle, for instance. In case of a circle or an equilateral triangle, R1 and R2 would be the same because all three sides are the same in an equilateral triangle, and the circle will have just one unit of definition, that is the radius. Remember from the previous lecture that in case there is an increase in dimension, the sign before R shall be a plus. In case the dimension decreases, the sign shall be a minus. Let us apply this shortcut on a sample question to understand it. We'll use the same question that we'd used before, that Rahul's bedsheet shrunk when washing, length reduced by 10% and breadth reduced by 20%. Now, we just substitute it in that shortcut formula. Percentage change in area is equal to 100 into 1 minus 10 by 100 into 1 minus 20 by 100 minus 100. This reduces to 100 multiplied by 0.9 into 0.8 minus 100, which is equal to minus 28%. Therefore, the percent change in area is minus 28%. The minus sign indicates a decrease. So this can be indicated as a decrease of 28%. So this one formula is very useful in any kind of a question involving some kind of a percentage. It could be profit and loss, it could be area, it could be interest rate. Knowing this formula will help you solve questions across the spectrum in the IBPS exam.